Okay, good morning. So I'll open an existing file. What I'm about to do is just basic steps to conducting an econometric analysis using reviews. So open an let me open an existing. Let me use this one. This is the one I used the last time. Let me use that. So I'll finish. So the first step in any econometric analysis is to conduct your unit truth tests, also called stationarity testing. To make this easier, I will open a Word file. Let me quickly open a Word file. And I will be pasting. Comment. Okay, so let's go back. Yeah, so the first thing is to do your unit truth testing. Unit truth testing, you come down here, you do them individually. Let's assume we have how many variables here: economic cost, GDP. See, doing this is not your variable. Your year is not your variable. This is the rough data set though. So let's go. To do that, you can open first. So let me just double click. So it opens. You come here, view. Of referring, but what your after is the unit truth test. So you click. So you see level. You see. You always leave at intercept. Always leave at intercept. There are different criteria. Can use the TRAS info. Can use the KIK info. Many times people choose to use their KIK info, so let's just use. Sometimes you can also use. I don't even check any of those two, KIK or TRAS. It's good. You can also use the ANAN like that, but let's just leave it at the KIK. Okay, so you first of all usually do level difference. In econometric analysis, it's usually best to do level and first difference. That's first difference is usually the worst case. It's not, you rarely use second difference, second difference variables, because if the variable is not stable at level, is not stable at first difference, using variables that are stable at second difference is not really the best. Now it tells you that there's a lot wrong with that variable with data. Okay, so always endeavor to use it within the level and first difference. So we'll start with our level. So we'll click. Let me expand. So you can see here at level, you just usually use this figure to know if it is stable or not. You can also use it in statistics, but this is the best, just not to stress yourself that much. So at level, you see that this variable I can't remember, it should be economic cost, is not stable. It's not stable because it is greater than the 1% or 5% level confidence level. Okay, so you want it to be less than 0.01 or 0.05. Okay, so at this point in time, this is greater than, meaning at level this variable is not stable. this variable is not stable. So you can just copy, Control A, Control C, then you come to a document file, you create an appendix, so because all your rough analysis will run here. I usually like using Times Roman. Okay, so you write, this is how you usually do it. So you write the name of the variable, so you'll be able to remember. Econ C. So if you check this one, so this is it. You just, okay, that's the variable there. So you write first difference also. I will just use one variable to illustrate this. So first, this is level. These are level. So you'll be putting the individual variables under. The one you do under level, you put it under label. The one you do under first difference, you put under first difference. First difference. Remember, you don't use second difference. So let's go and do the first difference of this now. Okay, so we'll go back. We just come here, view, unit root test. Now first difference. Remember, the former one was level, now it is first difference. So we'll go OK. Wow, you see here, everything is 0, meaning at first difference, we passed the unit root test, so stable. So what you just do is Control A, Control C, copy, come and paste under your first difference. Okay, the name, remember to write the name, though you also see the name at, within the name, but it's usually best to just write to make your work look organized. So this is same icon, C, this is the first difference. Okay, as I can see at first difference. So next you also do under here, at the level, if you're doing the next variable, for instance, you are, let's assume the next variable is what again? Next variable is so this one you can just remove this one. Let's say it's GDP, for instance. So let me just go and write it down to save me time. You can just write all your variables down, GDP. So once you come, you paste it there. You come in first difference, you say write GDP. So if you have like 10 variables, you do that under both heading, level and first difference. Just in case you're running it, you'll just be pasting it. So let's do GDP again to clarify this aspect. So view, unit root, let's do the level first. Okay, and see the level, you see GDP is not also stable. You copy, Control C. Okay, let's go. If you document this level here, level GDP, just come, Control V, GDP level, This one is first difference. View unit root test. First difference. Okay, that's first difference is good. Control A, Control C. So come here and paste. Okay, Control V. So that's how you do it till you're done with all your variables. There are sides to this, something you need to understand. If all your variables are at first difference, meaning there's none that is a difference at first level, at the level itself, then you can use the ACM technique, but if it's a mixed order, you cannot really use the ECM. We use the ARDL, and given as we're students, usually it is the ARDL. Most of our variables are of mixed order. You have the first difference, you have the partial difference. Okay, I'm coming. I recording those stuff since then. What did happen now? What did you know? Oh, it's still recording. Okay, so yeah, we'll get back to. I thought this thing stopped recording already. Okay, let's get back to what you're doing. So yeah, as I was saying, you have the mixed order and the normal order. The mixed order is of stationarity, is that if you saw the two that I've done now, they are stationary at they're stable at the first difference, non-level difference, meaning you can use the ECM technique. But if these are mixed order, you use the ARDL. But many a time our analysis of the mixed order, and there won't be chance to do both first order difference and second order difference. But let me just check any other for variable if there's anyone that's stable at level. So I'll just use that. I will be using the ARDL in this to save time and all that. So let me use the ARDL. Let me try. I've done. Okay, let me see if this one will be stable at level. Let me just, anyone that will be stable at level, I'll use it. This is not stable. Let me see this. Let me see. This is also not stable. And I don't have any variable here again. Let me just try something with this. This is not a variable. Let me see if I can use it to explain what I'm doing, if it will work. Yeah, let me check the year. If I can remember, here it's not a variable, but I just want to show you something. So that's okay. Let's just assume now that one of our variable, we have that brought another data set to explain that. Let's just assume that one of our variable is stable at first difference. That is, if we run this one now, let me just run this one again, for instance. If we run it again at level, you see here is level, we run it, we will see this place at that level, not the first difference, this value will be less than 0.05. If that's the case, meaning we have a mixed order of one. So let me just do this third one. Let me assume that's the case. Let me do this. I'll use 3 variables. No, I've done this one already, and this one is likely to be stable at first difference. That's the admin. There is no stable at level, so letting it be stable at first difference. This one is stable, so we use the 3 to run our analysis. So the next will be configuration, but configuration in using ARDL is what they call the bound testing. They call it bound testing, ARDL bound testing. That's what we use to know the test long-run relationship, if the long-run relationship coexists between two variables. So what you just do next is to go to your document file first, and you can call it co-integration or ARDL bound testing, but let's call it co-integration testing, because if you are doing just first variables are first difference, which you use ACM, which is not usually the case. You just type conjugation, and they have different tests, the Johansson conjugation test and all that. So conjugation you do, but the conjugation we are doing now is the ARDL bound testing. ARDL bound testing, because this is the one you most likely use, because your variables tends to be mixed order. ARDL bound test result. So I'll go and use the ARDL now. Let's go there. So as we just do is to select our variables, select this, select GDP, let's make GDP our, so select, can use more than, let me just use this, then open as equation, remember. So you come here, see how there you have different type here. ECM, you can't do ECM directly, because this is if 9 or 7 now, so you really can't do ECM directly. All you do is, there's a way they do it, so hopefully in subsequent videos I'll do that and clarify on that, so we get to understanding on that. So yeah, we just come here and do the ARDL. The ARDL has ECM also built in between, so you can also use the ARDL to do ACM. You just explain the ACM part of it. Okay, so let's go ahead. Okay, you leave everything as you were there. So let me explain. So this is your raw ARDL output result. Okay, this is your raw ARDL output result. So you can just explain this. Normal way you explain econometric results, you can explain that. Usually can see and see explain at first period lag, second period lag, like that. You just explain. You have your ARDL, your R square is good. This is your WASIN. You can, the other tests you conduct, what they call what was it called now? Trying to remember the diagnostic testing. So you can conduct your diagnostic test with what you do now. Let's, for instance, given that I'll come back to this, given that we are doing for ARDL bound testing, that's the conjugation test. We'll come here, we'll do residual. Residual is part of the diagnostic testing, so we'll come, and it's coefficient. Come here, coefficient, bound test. So bound testing. So bound testing, for you to know if your bound testing is okay, if you can progress with it. Usually work with 5%. The value you have here, your F statistics value, should be greater than what you have here. So it should be greater at least within the 5% and downward. So if you observe this value is greater than both at 1%, greater here, that will tell you that our variable is co-integrated with, they are all conjugated. There is conjugation, there is a long-run relationship between our variables, so you can proceed with using ARDL bound testing. You can proceed with conducting an analysis with this. So what you do, you just copy Ctrl A, Ctrl C, and you come this way to our Word document, and you paste Ctrl P. Okay, so you can delete all this part off. Okay, so maybe in subsequent videos I'll also show you how to, but I believe I've done this explanation. I'll send you a write-up on how to explain. I'll send a write-up on how to explain them for my students. Okay, so I'll come this way now. ARDL, back to reviews. So you've done the bound testing. Yeah, just depending on you can remember I told you can also use the ARDL for ECM. You can also explain the ECM part of it. So well, let me just go back to the normal estimation. So this is the first part of it. This was what we had earlier. Remember, you can go ahead explaining this one. Everything is in order. Everything is in order, but you can do your diagnostic testing later on. So let's just assume you want to do the short run and long run relationship. So you can come here, come this way, conjugation, yeah, and long run relationship. So this is it. So over. Estimate execution. I just went back, so I just run it again because that one went off. Okay, so you just come again, view, diagnostic, your again, coefficients, come here, conjugation and long run. So this conjugation form is your short run. You know how short run is. I'll also send my student files on how to explain short run. So this is your ECM. This is where you have your ECM. And remember, your ECM must be negative and significant, meaning the ECM in this analysis is okay. It's in line with theory. The theory states that your ECM, so you can just say change this for the right conjugation here to ECM. In newer version of if you that's how the right ECM, then that's in order. Everything is now explained the way do normal explanation for econometric results. Then you come here. This is your long run. This is just more like a long run relationship. You know what long run is. I'll also send you files on how to go about the explanation aspect of it. So you just copy all of them and paste. Let's just copy Ctrl A, Ctrl C, and let's go to our document file. I forgot, so I'm here to post the ARDL, the raw results or the results. So let's come this way and paste this. Let's call this a short run and long run. Short and long results. So let me paste Ctrl V. So you can just come and rename. I usually rename is going to go into short run form. Short run form. I just do that. You don't necessarily have to do that though. Because of I do it because the new English version usually make use of that. So short run. Why this contributing aspect I should change this to ECM. You can also leave it though, it's not like a picture, but let me change it to ECM. ECM. thing is saving. I don't want it to save, I don't need it. Let me just save it anyway. Okay, so that's that for that. Forget this thing model is first. Usually sometimes it comes before your this one, the bound test, but let's just put it here. ARDL model result. So you can end at that place your model result immediately you're done with your this thing, what was it called, your bound testing. You can just interpret your model result and you're good. Depends on the lecturer in our department, and it depends on what the researcher is looking for. So you can also proceed to do your short and longer results. It still depends on the end of your research, what you want to get. Okay, so but let's go back. Let me copy it and paste. Let me re-estimate it. So let me estimate it. Okay, so you can just copy Control A and come here and paste Control V. So it is from here you will now be copying and be explaining, creating tables above. To do you see how I do it in the file I will send to you? So this is the first, like the basic using ARDL, assuming that both of your variables, remember, are of mixed order. The variables in your analysis are of mixed order, meaning there are some that are stable at level and there are some that are stable at first difference. You get that? Okay, so that's that for that. You now come to diagnostic, what they call diagnostic testing. Diagnostic, you may not necessarily need this for now, diagnostic testing, but you see it in the file I will send, give diagnostic test. So you have your multicollinearity. I really do multicollinearity though, at least for the now, even that most of the variables make you that kind of multicollinear, so I don't really, sometimes I think I did that in my analysis, I can't remember now. Then you do your autocorrelation. Let's just autocorrelation, although they call serial correlation, any of them. Autocorrelation again, I'm trying to remember. I think is it that, so I don't know. That's an arrow. Autocorrelation. Okay, so a serial correlation depending on your choice of usage. So let's come back to our, let's do this is where you get your diagnostic test. So you come to the residual diagnostics first. You have all this one, but serial correlation, let's do serial correlation first. Okay, it's more than 0.5. so your target here is that these values, any of these values, is more than 0.05, it's more than 5%, because of the null hypothesis. It depends on the null hypothesis is that it is, it is autocorrelated. So but given that this one now is more than 0.05, meaning it has defeated the null hypothesis of this Bush-Godfrey serial correlation LM test. It has defeated the null hypothesis that the analysis is autocorrelated. This one, but given that this is against, it's greater than 0.05, means it is not serially correlated. Okay, so you just copy, see, then you see how I did that in my the file I was sent. So you understand this is the autocorrelation. You have the heteroscedasticity test. I'm not getting the spelling right now. Let's get that. Guess time. This spelling is not right too. Well, I was doing that. See that time. Oh. This is not the right names. The right names are there. Still for the other one, it is bush Godfrey, only bush pagan for heteroscedasticity. So let's come and do it here. Come again here. Come residual diagnostic heteroscedasticity test. You have the bush pagan Godfrey. So you just run OK. So this is also greater than 0.05. Control A, Control C. This is the heteroscedasticity test. You come here and you paste. Control V. And then well, let's just end with the let's do the third one here. There's two others though. Let's do, you have histogram normality testing. Let's do it. This one, you also want it to be greater than, it is greater than. Control A, Control C. Okay, still go and it's normality test. Write it normality test. Normality test. All these ones are just to embellish. Normality test. Control V. Okay, so that's that. With that, now you can also do the Ramsey. That was just try. So I don't necessarily have to do it here, but I'll just show you. I won't copy here. Under stability diagnostic, I usually use the Ramsey test reset. So the probability is more than. Let me just copy and paste, then I end it there. So it's stability. Test. So Control S. Then you now copy your variables and go and explain. It's as simple as one can explain it. Okay, so that's it with that. Hopefully you get what I'm trying to say. I just use the ARDL. I didn't use the CM. The normal row is here because of time factor on this. The usual case, most of analysis for us to there are still other methods. It just depends on the they have the VAR, the VECM and all that. So hope this helps for the now. If there are any other questions with regards to this, you can reach out to me. So you make a effort to subscribe to this channel, and if you have things that are not clear as enough, you can always reach out and I'll help out.